Sorry about that. I accidentally turned my computer off while trying to give you that video angle. But you see my hammer device here. And I just wanted to close out this thought before I leave you for the day, is how does this work? And again, it seems to defy gravities because it seems like, well, all the weight is over there. Hammer's very heavy. It's connected over here. It's not connected over here at all. Okay, there's no wires or anything connected here. And it's because that the head of the hammer is so heavy that the center of gravity, the whole system is like right here. It's below where I'm supporting it. And even though the hammer is not connected on this side, its weight is still over here. So it makes that center of gravity, down here. And so as long as the support is in line with that, and when the center of gravity is below a support point, things are extra stable. You guys may remember, I don't have it with me, but you guys remember a little balancing guy on my desk that was always doing this, that had two weights at the end of them, and kind of like that. The lower the center of gravity, the more stable something's going to be, and that is true to the point where even if the center of gravity is below the support point, that is the most stable you can be. And that's actually what's happening here, is that the center of gravity is directly below this center point. So I can even move this around and bop it up and down, and it's super duper stable. It's just surprising because it seems like this hammer is only connected over here. And so all of its weight is acting on here. And it is, but because a larger proportion of its weight, due to the heavier hammer, is on this side, it balanced out that center of gravity to get it right here, keep my support above that, and it is able to fall. Okay, so I will post these two videos for you. You're watching this, so you obviously know that. There'll be some questions, but that's basically it for center of gravity. Some neat things. Try out that head against the wall thing. Remember, your body needs to make an L shape. Your head into the wall, 2 steps across. Tell me in the comments why girls can do it generally and guys cannot. Not a hard answer, but has to do with weight distribution on their bodies, and just how differently. And again, this is not universally true, but it's pretty much true. 80-90% of the time that guys cannot, girls can. Think about what that means for where girls' center of gravity is as compared to guys on their bodies. I know it doesn't have to do with the fact that they're, girls on average are shorter than guys are either. Beyond that, I think that's it. I'll probably ask a few follow-up questions about things I covered in this video. From here, now that I'm done talking about center of gravity, we'll talk about something called rotational inertia, and wind down some rotational things. I'm kind of cutting it really short, but there are a lot of cool demonstrations in this chapter that I want to do in some shape, way, or form that kind of makes sense. So, and that are as interesting as they would be if we were doing all this in the classroom. So make sure watch all this, answer the questions in the comments. Again, tell me the boys versus girls thing, and tell me what you think. There'll be some points that way for you. Also, tell me if you were able to do it, and see if that winds up being true for the 34 or so kids that I have in physics. Again, I might give you guys a Google form or something that you guys can answer some questions about this these couple of videos for me too. All right, thanks. Have a good day.